Alright, time for a new reaction video. This time what we are doing is reacting to Dan North article on Cupid, which is his proposal to replace solid principles. So he's come with a set of 5 principles that replace the solid principles. And I found this very interesting. I learned about this, I think, a few months ago, and then North was still about to write the article detailing these principles. He didn't have them at that point, and so it was it's an interesting thing to check out, since we also teach solid principles, we apply solid principles. So let's see, is there anything better than what we are doing? Always interesting to see. Just a bit of background. Adi, I think you know more about Dan North than I do. He was involved in the team who did behavior-driven development for the first time, right?
Yes. So he was doing more programming, and Chris Matz was doing more analysis, business analysis, and so together they said, let's have a way to create a meaningful conversations around what we want to do. And from that idea of meaningful conversations, they started having that format with given, when, then, and they started thinking then that we could use this as executable specifications and as tests. So yeah, that's his background. Basically, he's worked a lot of his time either in banks or consultancy, or for banks or for big companies on these areas.
Yeah, and another, I guess the third musketeer in this group was Lisk, right? So
yeah, she arrived a bit later. But they were still discussing and trying to figure out what this new way of working is. She arrived a bit later, and in a way she crystallized. She was there when they crystallized and came up with some ideas. Yes, so, but yeah, the three of them are probably the people who created it and talked most about this topic of behavior-driven development.
And one thing I know about Dan North, I saw him live at I think it was CraftConf or the London Software Craftsmanship Conference. He does very, very good talks. He is a very good speaker. I really enjoyed his talk, and I appreciated a lot that he has a humane approach, a human approach, or a humanistic approach. It's not only about code, but it's also about, communication and working in a team and all these things. And I really loved this.
Yeah.
All right.
BDD is part of it in a way. So if you look at BDD, that's what it should be, the humane part of it.
Yeah, so we could say that we like Dan North. This is not personal. It's just we want to look at what he said and see if there's anything here, right?
Yeah.
Okay, so we'll start with the first article, which is called Cupid, the Backstory. These are articles from his blog. As you've seen, this was published on 16 March 2021. So basically the idea was that he was participating into a conference in a pub, kind of a fun, let's say, side event for conferences. And he has he did an Ignite style talk. If you don't know, these are very short talks, so you have to be very on point with them. You cannot talk a lot on every slide. And what he did was, let's see if we can write about, or if we can criticize solid principles. And he took fundamentally, this is the talk. He took every one of the solid principles and replaced them with write simple code. That's fundamentally what he did. And there's a bit more here. So you start with things like single responsibility principle, and his criticism on this. Okay, so there are two ways of thinking about single responsibility principle. Code should only do one thing. Now, a bit more here, because actually the principle is also about modules. Modules should do one thing, functions should do one thing, classes should do one thing, and that one thing depends on the level on where you are. Or has one reason to change. And his criticism for this is that it's a pointlessly vague principle, because you don't know what one reason to change means. What do we believe about this?
It is vague. I think in most of the trainings that I had, or discussions that I had with people, it is not easy to understand, especially because if you read about it, so there are two ways here to look at it. It's this saying, we just have one reason to change, but then you need to look even deeper and really read about it in the book, where it says, you have actors of the system. So you go back to a kind of analysis that's not quite common today. When you look at the actors of the system, that's like 80s, probably, maybe 90s, late 90s, you'd still see something like that. But it's more like the 80s analysis with UML, where you'd have the actors of the system and you'd like to have only one actor intervening for a change of that system. So if you have, I don't know, you have a module that computes salaries, probably you'd have the actor accountancy, but also you'd have the actor, I don't know, legal department. So if one change of that module means requested by the accountancy, means that that change will be reflected also for the legal department without them requesting. That's a break in the single responsibility principle. So this view, this concept is not easy to understand. It's very difficult to get, especially because people are not used nowadays with this analysis of actors. I don't even know if it's taught in schools anymore. As far as I saw with interacting with young developers, they don't understand this. So it is vague from this point of view. And I think it's as good as it could be at that moment, right? Let's not forget that this was defined somewhere in the 80s, right? So it's not a new principle. So I think it relates to the way of how analysis was made in that moment.
Yeah, and just to add something, it's often believed that the solid principles were created by Robert C. Martin.
No, yeah.
Actually, what he did was he collected them, because those principles were around, and some of them are older than the book or the first article where they were published.
Older,
yeah. So they are actually the wisdom of that time, and that time involved often other types of applications. We had applications that were client server maybe, and the clients and the servers used special binary protocols, and you had different modules on the client, and on the server you had fat desktop applications that were packing a lot of features in them. You had a lot of databases and reporting modules built on top of databases and things like that. So it is indeed, so maybe it sounds a bit old style.
Yeah.
Right.
Exactly. I think that's why it's difficult to get, because it's old style and it corresponds to a certain way of looking at business requirements that nowadays is not at all common.
Yeah. And so his suggestion at that point, then North's suggestion, was to write simple code using the heuristic, it fits in my head.
Which is vague again.
Code should fit in your head at any level of granularity, whether it is at method thought function level, class module level, components made up of classes, or entire distributed applications. Yeah, but it's vague again. You might ask whose head? I assume the owner of the head can read and write idiomatic code in whichever languages are in play and they are familiar with the problem domain. And then he adds, at each scale there should be enough conceptual integrity that you grasp the whole at that level.
Oh, so we introduced conceptual integrity, which already is a very difficult idea. And
Yeah.
I mean, okay, single responsibility is vague, but conceptual integrity is extremely difficult to get. It's not necessarily vague, but it is extremely difficult to get, especially when we talk about siloed developers.
Yeah. And let's not forget that we are talking about conceptual integrity at multiple levels. So there should be conceptual integrity at function level, at class level, at components level, at this application level, and so on.
UI level, everything. And you need to go all the way to executable specifications and all the way to so maybe we need to explain what conceptual integrity is in very small in a way, right? It means that if you have a domain concept, you'd like that domain concept to be repeated everywhere in your code, in your documentation, in your tests, in your deployment pipeline code, in your scripts for, I don't know, automating everything. If you have one domain concept, it should be reflected everywhere. So let's say that you have a domain concept called customer. A customer should not be replaced in your code or anywhere in your documentation with the domain concept client or user, whereas it could only if it means something else. But if it means the same thing, you should use that concept. So that's very difficult to get, I think.
I think it's even worse, well, worse than that on the vagueness, because my feeling is that he refers to conceptual integrity at these various scales, which means that actually you have different concepts in a function, you have different concepts in a module, different concepts in a class, and the collection of those concepts has to be to form this conceptual integrity. So you should be able to understand what a function does in isolation because it makes sense in isolation, right? Mm-hmm. And what a class does in isolation because it makes sense in isolation.
Yeah.
So in a sense, it's the same idea, single responsibility, only stated in a different way.
Yeah, but introducing conceptual integrity doesn't make this idea simpler to explain. It's more confusing. It's not that vague, maybe, but it's more confusing, I think.
Yeah. Okay, so that's where we are here. I'm curious to see what he replaced it with in the end. So we'll get there. Open-close principle. Code should be open for extension and closed for modification. He says this was sage advice in an age where code was expensive to change, risky to change, mostly additive. So you needed to always add code. Nowadays, the equivalent advice if you need code to do something else is change the code to make it do something else. We think of code as malleable now like clay, where in the olden days the metaphor was more like building blocks. There was no feedback loop between the spec and the code like we have with automated examples. Okay, so what do we think about this?
I think I agree in this area. I think open close is still useful where, in a way, to understand not to touch code that shouldn't be touched when you come up with a change. So maybe it relates with the next one, with the Lisk of substitution principle. I think you need to understand that code should be closed for change, in the idea that if you need to change in many places, probably you have a problem with your code and how it's structured. Probably you have a problem with your architecture, with your design. But otherwise, I totally agree that now we have feedback on, we don't necessarily need open close. There are though some areas where I would still apply it, where you need to have modules that are independent of the rest. Sometimes there are areas on the code where you change often, like business or modules, but they are also modules of the code where you won't change a lot or quite often. And I think there you could apply it still.
Yeah, so my feeling is that I would love to see code that's malleable like clay. But the reality is that my intuition with code is that it's more, maybe it is like clay, but it's like clay that becomes cement after a while. If you don't pay enough attention to maintaining it as clay, you will have a lot of troubles ahead.
Mm-hmm.
And just a few things that you can do wrong. You can have no tests, right?
There you go, because he says you can you will have feedback from your examples, automated examples. So
yeah. So if you have no tests, then your code is not like clay. You cannot change it easily.
yeah,
If you have tests, but those tests are slow,
yeah,
cannot change the code easily. If you have tests, but your tests, let's say they are fast, they could be fast, but your tests are deeply coupled with your code.
mm-hmm.
Again, you don't have clay in your code.
It's difficult to change. So what you're saying is that if you have his remark is right, if the cost of change is small.
Yeah. So I think so. I mean, you can have code like clay. You can change the code very fast. But even then, let's not forget that there are, okay, you have tests, fine. No matter how well you write the code, there will still be areas that are a bit weird in your code base because you have to deal with some weird things in the outside world. Let's say your code is perfect, but you need to interact with external services or whatever the next the programmer next door wrote, and it's not that great. So you still have some parts of the code that are more difficult to change than others. That's my feeling in general. So I agree in principle, but I think it's a bit idealistic to think that you will be able to change the code whenever you want it to make something else.
I remember that exactly about this point, NetPrice had a very good article, I think a few talks on this idea that architecture is like nature. It's never perfectly aligned how we'd like buildings to be, or how we make things perfectly arranged. But code has some noise, has some areas where we still won't have order. And that's natural to us as humans, and it's natural to the fact that it's a huge cost, or even it's quite impossible to an extent to have everything extremely ordered.
Yeah. And I'm thinking just take another simple example, but something that happens all the time. Let's say you're doing, I will take JavaScript application. So you have Node.js on the server, you have React or something on the client side, and you build it using the best, cleanest code you can write, you have tests and so on. And then suddenly a new version of React.js comes that changes all your design patterns. And you have to switch to the new version because you need some kind of features or something like that.
Yeah.
How do you use clay here? And Yeah, this is real life. So again, I find it a bit idealistic. I understand where he comes from, because if you come from the extreme programming community, and you are surrounded by people who know how to write this type of code
Mm,
and who know how to manage it and so on, then yeah, it
yes,
works. And
yes,
they know how to deal even with these challenges that we described. But if we talk about the average programmer, okay, we will have a bit of a problem there.
yeah,
Yeah. So in principle, I agree. A bit idealistic. Okay.
yeah.
Lisk of substitution principle. By the way, he said this is the one that he agrees with, which
Mm-hmm.
is, I mean, obviously,
Yes.
it's hard not to agree with it.
Mm,
What he says is that it's just the principle of least surprise applied to code substitution, and as such is pretty sensible. Yeah, of course, I agree with this. Now the thing is, what he says is, in the spirit of using a butter knife as a screwdriver, many objects can act like a and sometimes be used as a or pass off as a if you squint. I like this. In this context, what we really want is small, simple types that we can compose into whatever more complex structures we need, and to make our peace with all the nuances that go along with this. My advice is to write simple code that is easy to reason about. Okay, so I agree with small types.
yeah.
I agree with having types that are very specific precisely for what you need. Think about your objects very carefully to fit into precisely what you need. Still, I think, yeah, and actually he says that the language LSP uses of subtypes, coupled with the way most developers conflate subtypes with subclasses.
Mhm.
So this is a very important thing that very few people understand about Lisk of substitution principles. Subtypes do not necessarily mean inheritance.
Yes.
Do not necessarily mean subclasses. You can have a subtype relationship between two classes that have absolutely no direct relation in the code.
Yeah, you can think about mixins,
Yeah.
for example. But let's go a bit to the history, because the history is important in this situation. Barbara Liskov, who created this concept, she's a mathematician, so she created this concept, I don't know, somewhere in the 70s something, and presented it to a mathematicians gathering, where she doesn't talk necessarily about classes in the programming sense. She talks about sets, so mathematical sets. She talks about types and subtypes of that uh, thing. So we basically need to understand a bit of mathematics, go back to the basics of sets and set theory, and that's what she talks about. And if we go to mathematics, that means is that you have a set which has some rules, some definitions, and if you define a subset, that means that that subset will have the same rules or plus more others. So that's where she's coming from, and that's what subtype is this idea. We talk about subsets, and I think that's very confusing when we read Lisk of substitution principle and we don't explain this whole background and history.
Yeah. And so in this case, I actually agree that talking about principle of least surprise applied to code substitution, that's much easier to understand.
It is because that's what it should be. And I think what's also missing about code substitution is not only about that, hey, we put another class or I don't know, another thing there. We should always talk about behavior,
Mm-hmm.
because that's what subtype is. It's about internal inherent behavior. Let's say that, I don't know, we have an algorithm that knows how to sort. We should care about how it's sorting. we shouldn't just care that, hey, it sorts somehow. That's important. So that's an internal behavior that we need to test, we need to check, we need to understand. And again, we need to go back to mathematics because it's a mathematical concept here. So it's not just about defining a class and, hey, we have these methods, these properties, I don't know, whatever, and that's all. If we have the same things, it's okay, we respect Lisk. It's not true. We need also to check the implementation of those methods if they respect the principles behind it.
Right.
It's much more deeper.
Yeah, and I agree. And actually, another interpretation or connection with between Liskov substitution principle can be made with design by contract, where fundamentally what you have is you have a contract formed by precondition, postconditions, and invariants for each method, and that gives you how would you say, the set of properties of that set.
Mm-hmm. Exactly,
That's basically what it is. And the same contract should apply also to subset. You should only be able to add more conditions to it, but not remove any of them.
Typically, when I was explaining this, this is a typical bridge, especially in, I don't know, C# or Java, but especially in C#. When you say, okay, I'm implementing something, some interface, I'm respecting Liskov because I'm using interfaces, right? But then for one of those methods, I just throw not implemented exception. And it's fine, right? Because I'm having the same interface, the same thing. But hey, you're not respecting the contract. You should do an implementation of that method that says sort. You shouldn't throw not implemented exception because the client who's using that is expecting you to sort, not to throw not implemented exception. And there you go to the principle of least surprise. So that's why tests are essential, or examples, automated examples are essential in checking Liskovs.
Cool. Next one, interface segregation principle. This really is a fish in a barrel as principles go. For some reason, this one caused the most controversy, but to me it is the easiest to debunk. I discovered that this pattern came about where Robert C. Martin was wrangling a God object in the middle of some printing software at Xerox. Everything was happening in a class called job. His approach for simplifying it was to find each place where it was used, figure out which methods went together, and put those in an intermediate interface. This made a few benefits. Okay, all of this makes sense, just that it isn't a principle, it is a pattern. A principle is something that is generally good advice in any context. Okay, and what he said is that I argued that if this were a principle at all, it was the stable door principles. If you had small role-based classes in the first place, you wouldn't be in the position of trying to decompose a huge tangled mess. Sure, we may find ourselves in the context from time to time, and when we do, interface segregation is a perfectly cromulent strategy for slicing your way towards sanity, along with building a suite of characterization tests and, refactoring using Michael Feather's methods. I mean, I agree partially with this. Again, small role-based class is much better than one large class. That's not even a discussion for me. That is obvious. But I'm not sure that interface segregation principle only talks about this.
Yeah, I think it goes a bit more towards coupling or decoupling, because what's saying there is that, hey, you had the God class and then you split in more. Okay, but if you use interface segregation principle, you can easily think that you reduce coupling, because the level of basically you should look at how things are related and couple only with interfaces the different concepts around you, because that's what interfaces are. There should be the module or the model, the way of coupling things together, right? So yeah, my favorite example is a plug, right? You have a plug in European style, the UK style, American style, etc. So that's your interface. That's the definition of your interface. And then you have the different type of implementations like UK, European, so on. But both have the same thing. They have current, and you have a coupling, right? So you have the surface on which you plug in your whatever tool in that. So that's what I think you need to define, the way of coupling your different systems. And that's where I think thinking in this way of the interface segregation principle helps. And it's not necessarily about classes. It's about coupling, I think.
And it's also about cohesion in a sense, because we are talking about, when you talk about interface segregation, we talk about keeping the smallest part. Okay, so let's say you develop something using test-driven development, and you end up with a somewhat larger class in your implementation. This can happen, right? It's not maybe you're focused on figuring out solutions to the problem and then refactoring a bit later. A bit later doesn't mean 2 weeks later, by the way. It means 2 hours later, or maybe tomorrow. 1 day later, or something like that. Yeah. And when this happens, it's useful to look at that class and figure out, okay, so what are the objects that are trying to get out of this?
Mm-hmm.
Right? And this is something that you can do. And interface segregation for me also talks about cohesion, in the sense that I'm looking at that and see, okay, so these 3 methods belong together, but the other 4 don't. So let's extract that thing, and then let's extract another thing, and so on. It doesn't have to be a God class. Mm-hmm. It can be a slightly smaller class. Yeah. Now, of course, since we are talking about this, you probably can replace every solid principle with understanding coupling and cohesion, or more than coupling, connaissance.
Which is, again, like introducing a very complex thing to explain. I don't know.
Yeah. And that is the problem, because we are on different levels of understanding as developers, and solid principles give you a start, a good start, I would say. Maybe not the best one. Maybe we'll find some other things. Okay, so in principle, I agree. If you do small role-based classes, yeah, absolutely, do that. You don't need to think about interface segregation then. Think about coupling, cohesion, and you'll get to simple role-based class.
Yes.
Dependency inversion principle. While there is nothing fundamentally wrong with it, I don't think it is an overstatement to say that our obsession with dependency inversion has single-handedly caused billions of dollars in irretrievable sunk cost and waste over the last couple of decades. Okay, that's a bit of a...
I don't know.
Maybe.
I don't have any data on that. I don't know.
Yeah, I don't have. Maybe, there is one problem with dependency inversion principle, and that is that many people confuse it with dependency inversion frameworks.
Definitely. I think that's where it went bad.
Yeah. So just know it's a principle. You can also have a pattern derived from this. It's not necessarily that you need to use, I don't know, Spring dependency inversion.
Yeah.
The real principle here is option inversion. A dependency is only interesting when there might be multiple ways of providing it. You only need to invert the relationship when you believe the wiring is important enough to become a separate concern. That's quite a high bar, and mostly all you ever need is a main method. I mean, that kind of defeats the purpose of tests.
Yes.
Because often in order to test, you also need to decouple things and to be able to plug in test doubles. And that's where dependency inversion helps, because you can also plug in, actually use dependency injection, which are two similar concepts, slightly different, but kind of in the same vein. And that allows you to options, right? That's one option that you might need. Now, of course, actually, is he part of the London School of TDD or Chicago?
Well, if you want to go on that rabbit hole, yes, but it's a more difficult discussion, let's say.
Because I think the reason I'm asking is fundamentally London School was with mocks and stubs, right? So using
with mocks, yes,
with mocks. So actually injecting test doubles into the code. So how do you do that if all you have is a main method?
Through the main method, I guess.
All right.
I find it really unclear what he means by that. I'd like to see it working. I'm not convinced at all.
If instead you subscribe to the idea that all dependencies should be inverted all the time, we don't, you end up with J2EE or SGI Spring or any other declarative assembly framework where the structuring of components is itself a twisty maze of config. All right. So I agree with this. That's a total mess. You don't need to do that. All right. Most dependencies don't need inverting because most dependencies aren't options. They are just the way we're going to do it this time. So my suggestion is to write simple code, but focusing on use rather than reuse.
Okay. So I think what he wants to say, in fact, is that not everything needs to be inverted. And you only, that's what he means by option. Only where you need it, you should have the option of inverting, which I totally agree. And then you shouldn't use a tool for dependency inversion, dependency injection, but I think you should be more wise and to understand what needs to be inverted and what not. And while I think he showing what you need to invert or not, it depends on your usage, and the first usage of that is your automated tests.
Yeah, absolutely. And it actually also relates with the behavior-driven development, because one of the ideas there is to test behaviors instead of testing classes. I know.
Implementation.
Right?
Yeah.
So because you test behaviors, one thing that can happen is that a behavior can go through multiple objects. And you don't necessarily need to replace every object with a mock in order to test the behavior. In fact, it's quite annoying to do so, because you will end up with a lot of tests that are kind of duplicate. So when you are doing that properly, absolutely, you don't need to inject everything for tests, and therefore you don't need dependency inversion for everything. You just need for those things where you either need to inject something for tests, a mock or a stub, because of some, I don't know, it's too complex, it's in another module, it's in an external, or a connection with an external thing, or because you actually have multiple options. So let's say maybe you have a database that's a text file, but also a database implementation that's a NoSQL, MongoDB or something.
Yeah, so I think, but here I think he's making a bit of a confusion. That's more of the bad usage of this principle that he saw. but I also saw it used in other ways, more better, or in the way that I think it should be used.
Mhm.
I wouldn't criticize the principle itself, but how it's used maybe in a very big range, especially what he says there with Spring, J2E, and other stuff like that.
Yeah. So I completely agree. You don't need to invert and to inject everything through Spring. That was so annoying all the time. Cool. So this is what he said. Let's see now what he proposes as an alternative.
Mm-hmm.
And he proposes Cupid properties. By the way, he published this just a few days before Valentine's Day, which is funny in itself. And because it works with Cupid. So he said composable plays well with others, unique philosophy does one thing well, predictable does what you expect, idiomatic feels natural, domain-based, solution domain models the problem domain in language and structure. And he starts with a preamble on joyful software, which basically refers to habitability. Very interesting concept. When I wrote about usable software design and when we were actually looking at this idea, habitability was the closest one to usable software design that I could find. But it's still, so I find it a very good idea, not used often enough, and I think made more practical if you look at the practices of usable software design. Well, that's a different thing. All right. He replaced principles with properties, qualities, or characteristics of code rather than rules to follow. Okay, good principle. And okay, he set some rules. I'm gonna skip over that because if you are interested in that, you can look some more. So the first one from Cupid is composable. Software that is easy to use gets used and used and used again, and this leads to the need for composability. And splits this into a few things. So small surface area, code with a narrow opinionated API has less for you to learn, less to go wrong, and less chance of conflict or inconsistency with other code you are using. So fundamentally small objects, small APIs.
Yeah, and coupling, cohesion again.
Cohesion, right? High cohesion, low coupling, because if you have a smaller surface, then it's less likely to get coupled with other things.
Of course.
Intention revealing is the second part of composability. I can easily find your component and just as quickly decide whether it is the thing I need or not. Yeah? Give it an intention revealing name. Absolutely. Ideally, domain-based code. Yeah.
Yeah, totally agree.
Totally agree. Minimal dependencies. I so much like this rule. Having minimal dependencies is an art that has been lost to people. That's one of the reasons I find so annoying the JavaScript environment. And not JavaScript language in itself, because you can use JavaScript by itself and with a few things. But when you go into things like React.js and so on, and you download 2,000 different small packages, each of them doing, I don't know, some string concatenations thing. Oh my lord. We need fewer dependencies. So what do we think about composable?
Yeah, I think it makes sense. I don't know why it's called composable because it's much more than composable. So it's about coupling, it's about how it's named, it's about dependencies. Are these characteristic of a composable thing? I don't know. I think other things can be composable, not necessarily if they are not in, if there are minimal dependencies, but I don't know.
I
Could be.
think so. When you have them small and with a very small surface area and with clear names and so on, it's easier to find
It's
those
easier.
things that you can use, right?
Yes, yes,
And
yes,
then
yes.
make precisely what you need to
Mm-hmm.
for
Yeah,
your code. So
sure.
that's, yeah, so thumbs up, I think.
Mm-hmm. Looks
It
good.
makes sense. Unix philosophy. I'm a big fan of Unix philosophy. Um, what it says, do one thing and do it well. Single purpose.
Yeah, exactly. In a way, I think that some people really understand single responsibility as single purpose, and it's one way of looking at it. I often explain Unix philosophy together with single responsibility, so I think it makes sense to go in this route.
Yeah, predictable. Behave as expected, deterministic, and observable.
Yep.
So this is the next one. Okay, so this ends the Unix philosophy. Says a simple,
Yes.
consistent model with single purpose. Um, Absolutely agree. In fact, the way sometimes I need to write some small tools for our internal use, and some of them are actually getting to be open source on our GitHub repository for Mozaic Works. And I ended up with a very simple procedure whenever I have some problem that I need to solve. First thing I do is try to solve it using a bash script and use the existing tools from Unix to solve this. It's amazing how many things you can solve with this. Okay, the syntax is a bit weird. It has some drawbacks and some weird behaviors sometimes. And all right, so it's not the ideal way of solving some of these things, but it's a good first prototype. And once you figure out how to solve this, then it's easy to turn it into a Python implementation and then into a AWS Lambda implementation in Python. It's as easy as that. And this composability is so great for this. I like to see more composable software, more Unix style software. Cool. Predictable. The third one. Code should do what it looks like it does, consistently and reliable with no unpleasant surprises. Yeah. Predictable code should behave as expected, should be deterministic and observable. Behave as expected mentions 4 rules of simple design by Ken Beck. Of course, you should have tests, and those tests should prove that your code behaves as expected. Deterministic, absolutely. This is where we need to have fewer mutations, more immutability, because that's where things help. And
It's
observable,
tough. Yeah.
right?
So about this whole chapter, let's say, it's very tough to explain this. So predictable, you need to understand the 4 rules of simple design. To understand the 4 rules of simple design, you need to understand a bit of evolutionary design or more. You need to understand automated testing and unit testing. For deterministic, you need to understand immutability and how it works and where it makes sense. So I'm thinking from my point of view of interacting with a lot of programmers who want to learn design. this whole thing is very difficult to grasp, I think. I'm not saying that it's bad. It's a bad principle. It's a good principle, but I'm not sure how fruitful it will be in real life.
Yeah. I mean, he kind of admits that because there are, so for observable, there are 4-stage models. First level instrumentation, your software saying what it's doing. Most software does not even get past step 1. So,
Yep.
absolutely. So it's good, very good idea. I like to see more code like this. I think we need more patterns that go in this direction.
Definitely. I'm just not sure who will get this. That's the whole thing.
Yeah, and unfortunately, so fundamentally what you need is a combination of domain-driven design, domain modeling, with something like hexagonal architecture.
Yes.
Or another way to call this is immutable core, and I don't remember how he said this. Immutable core and mutable externals, kind of.
Exactly.
But the core is something of your application can be completely immutable. Everything that is random, that is time, that is can be passed in as a parameter. All right. So we agree with it, but still hard to do. Idiomatic. Everyone has their own coding style. Okay.
Yeah,
This can add significant extraneous cognitive load in working with unfamiliar code. The greatest human programming trait, the greatest programming trait is empathy. Empathy for your user, empathy for support folks, empathy for future developers. Any of them may be future you. Absolutely. However, I have to mention that I wrote a series of tweets at some point, and one of them kind of challenging tweets, and one of them was that software development is fundamentally a humanistic activity, and that was the most that got the most negative comments. So we still don't understand this.
So I agree with these principles. I try to explain as much as possible, but I don't think we're there yet, and I don't know when we'll be there yet.
Yeah.
So the base on which he states that this should happen is not there.
So actually, this is where what we looked at when we thought about usable software design as well, is how to reduce this extraneous cognitive load.
Exactly, yes.
So, of course, we agree with this, but it's very far from happening. All right, so we have language idioms. I'm not going to go through this because we know what those are. And then local idioms that make sense locally. So idiomatic makes sense, relates with domain-driven design as well, because you need some rules there. Absolutely. But hard to do. Domain-based. This is the last one. We write software to meet a need. Whatever its purpose code should convey, what is doing in the language of the problem domain to minimize the cognitive distance between what you write and what it does. Obviously. Use a domain-based language and a domain-based structure. There's more here if you are interested in, but fundamentally, when you look at the structure of your application, you shouldn't see things like models, views, and controllers, because that doesn't tell you anything about what your application does. But you should see things like invoices and I don't know, accounts, and right, because that will tell you what the application does, not things like models, views, and controllers. So again, I don't think there's anything to add here. I agree.
No, there's nothing to add here, but I think you need to understand domain-driven design, which already is it's difficult. So I'm going back to my role as a trainer and coach, and trying to get with meeting with many developers that want to learn. So everything that he states here is very far away. I don't know. I wouldn't say which percent of developers would get everything here, but it's extremely small.
Yeah. Okay, so let's final conclusion. What do we think? Let's think about it this way. Should we still teach Solid to developers, or should we switch to Cupid?
I don't know. I think Cupid as it is now, it's difficult to teach. You need to start off with the other stuff, with the smaller titles, let's say. And if it of those smaller titles is already a very deep topic. So after that, if you teach every of those smaller topics, I think you already understand, and Cupid is not useful anymore because you'll get everything. Whereas Solid is more of an entry point into understanding design. It's simpler, and maybe that's one of its problems, but it's also one of its powers, that it's simple. It doesn't explain all the intricacies, but it's easier to get, I think. So I would still go with explaining Solid to junior programmers or programmers who want to learn more about design.
Yeah, and I think for me this is very interesting. I see a lot of parallels with usable software design, which is very close to my heart. And I think you can learn a lot about design if you follow these things, but just figuring out a domain language for your application can be something very, very hard to do for many programmers. So
yes.
Yeah. Okay. So I'm not sure if this is the conclusion that you expected, but this is basically our conclusion. I hope you found this conversation interesting. What did you think overall, Adi? Is it something interesting to look into in the future?
I think it is interesting to look, because it brings a more, let's say, up-to-date view on how software should be.
Yeah.
As I mentioned in the beginning, Solid is 80s way. Now let's try to look in the 20s way of looking at the software, and yeah, it's an updated view. I think it's very useful.
But honestly, if you want to learn the deep principles of design, what you should look at, and that's my opinion, you should look at, okay, domain modeling, absolutely important, coupling, cohesion, and the extension of coupling, connaissance. These are the topics that will give you a lot of important ideas about design once you understand them. If you use those, you will derive all these principles by yourself.
Mm-hmm. Yeah.
Okay. So I hope you enjoyed this. Time to end. Yet another reaction video. We tried to do this. It was a very interesting topic that we are passionate about, software design. Once again, we like the North. This wasn't personal, it's more about the ideas. We agree with him most of the times, apparently, but we also realize that we are a long way as an industry, and since we teach a lot of developers, we know that these things are a bit difficult to for many people to grasp. But I would be very interested in learning more and in teaching these things to people. Thank you so much for watching, and tell us if you want to react to anything else. And until next time, remember to think, design, and work smart.